Okay, so this topic here is an important topic, and it's differentiation. The reason that I say it's important rather than tricky is because the first parts of these questions usually tend to be tricky, and that's where you've got to prove this and this one here. However, when we've done that, the part D and part E, people can do because that bit is not very tricky. But a lot of people just give up on D and E because they can't do A, B, and C. So what we're going to have a look at here is, first of all, how to do A, B, and C. But if you don't understand how to do that, don't worry. Just as long as you're aware of how to do part D and E, so that you can pick up at least sort of 5 to 7 marks on this question. This is going to overlap with another video that I'm going to do next. The other video I'm going to do is based on sectors and segments and whatnot. And we're going to involve that in this question, but there's going to be a separate video on that as well. Anyway, if we have a look at this question here, this was the 2016 final question. So in theory, it should be the hardest question, and we're going to see how to do it. So we've got an enclosure ABCDEA, which holds sheep. And it consists of a rectangle, BCDE, and an equilateral triangle. Now, equilateral triangle there, that's going to be important in this question. And sector FEA over here. Now, what we've got to do is we've got to work out the exact sector of FEA. Now, to work out the area of a sector, it's going to be half r squared theta. The theta is this angle here. Now, the issue is that, well, first of all, we don't know what the radius is, but we know that it's x, so we're going to have to write it in terms of x, but we don't know what the angle is here. But we are told that ABF here, this is an equilateral triangle. So it means that each angle is going to be 60 degrees. Now, we need to know what 60 degrees is in terms of pi. So we know that pi radians equals 180 degrees. So if we divide that by 3, pi over 3 is going to be 60. So in terms of sector FEA here, it's going to be a half times by the radius squared, which is going to be x squared, times by theta, which is going to be 120 degrees. If pi over 3 is 60 degrees, 120 degrees, it's going to be 2 lots of pi over 3. It's going to be times by 2/3 of pi. Remember, 2 pi over 3 and 2/3 pi are exactly the same thing. And then if we put that in its simplest form, that's going to be, if we multiply the numerators, that's going to be 2x squared pi, or 2 pi x squared over 6. And we'll write it this way around just because, remember, pi is a number, so that's going to go before the variable, which is x squared. Okay, so given that BC is y, so that's part B now, show that this thing here, and we've got an area of 1,000 meters squared. So we need to work out what the area of the entire shape is. And hopefully it should end up looking like that. Again, it's worth 3 marks, so where do we start with it? Well, first of all, we know that the area of this bit here is 2 pi x squared over 6. Or, in fact, we didn't simplify it as much as it can, because obviously 2 over 6, that will simplify down to pi x squared over 3. Ooh, almost dropped that mark. So just be careful with that. So we know that the area of this thing is pi x squared over 3. So we've got pi x squared over 3, plus the rectangle. Now, if this is x and this is x, that's going to be 2x, times by this. So we've got 2xy, that's the area of the rectangle. And now we've got to work out what this is here. So the area of a triangle in C2 is going to be half AB sine C. So that's going to be a half times these two sides here, that's this one and this one, plus sine of the angle in between it. So they're both x, so that's going to be half x squared, and then sine 60. So sine 60, hopefully you should know what sine 60 is. But if you don't know what sine 60 is, there's 2 ways to do it. You can just do it on the calculator. However, if you know the 1 to root 3 triangle, but that is 60 and that's 30, then sine of 60, sine is SOH, it's going to be the opposite over the hypotenuse. So it's going to be root 3 over 2. It's going to be times by root 3 over 2. And then all that equals 1,000. So if we then tidy it up a smidge so that you can get it looking like this, because we've got to get y by itself. So pi x squared over 3 plus 2xy plus root 3x squared over 4 equals 1000. Well, if we get this and this on the other side, so that's going to be 2xy equals 1000 minus, we've got the pi thing next, so minus pi x squared over 3 minus root 3 over 4 x squared. And what we can now do is we divide through by 2x. So if we do that, we're going to get y equals 1000 divided by 2x is going to be 500 over x. This thing divided by 2x is going to be minus pi x over 6. By this thing by 2x, and that's going to be root 3x with the 8 on the bottom. Because remember, if we divide by x, it's going to take out one of these squareds and one of these x squareds. And so now we've got to be careful, because if we have a look here, we've got a plus sign. And here we've still got a minus. But if we then say 500 over, so y equals 500 over x. And if we take x over, in fact, we've got to make it x over 24. So minus, so we put in brackets, 4 pi x over 24. So times top and bottom of this one by 4, times top and bottom of this one by 3, plus 3 root 3 x over 24. Now the reason that we've got a plus here is if we then multiply it out, minus times this is going to be minus, and minus times this is going to be a minus. If we had a minus inside the brackets, a minus times a minus would be a positive. We want this to be negative. So that's where the plus sign is going to come from. And if we take out, if we factorize out the x over 24, what we end up with is y equals 500 over x minus x over 24, 4 pi plus 3 root 3, and then we've put in enough steps there that we've shown this thing here. And like I said, if you can do that, fantastic. If you can sort of start to do the first bits, again, it's really, really good. However, if you can't, don't beat yourself up over it, because part D is coming in a second, and that's going to be the important one. So now what we've got to do is we've got to show the perimeter equals this. So if we clear the screen there from all that jazz. So the perimeter. Let's start off with E down to D and then going across. So what we've got is we've got y plus 2x plus y plus x plus this here. Now the way we do that there, if you remember, that was 2/3 pi, and the way we work out the arc length, so arc length equals r times theta, so that's going to be x times by 2/3 of pi, so plus 2/3 pi x, and that equals the perimeter. So now if we sort of simplify that a little bit, we've got the perimeter equals 2y plus 3x plus 2/3 pi x. Now what we know from the previous question, because it says hence, so we're going to use the previous question, we know that y equals this. So again, even if you haven't done B, you can still have got part C. So the perimeter equals 2 lots of whatever that was, so that's going to be 500 over x minus x over 24 lots of 4 pi plus 3 root 3 plus 3x plus 2/3 pi x. And then it's a matter of expanding it and simplifying it so that it looks similar to that. Well, it looks exactly the same as that, not similar. So if we multiply this first bracket out by 2, that's going to be 1000 over x. If we do 2 lots of x over 24, that's going to be x over 12. And then if we multiply out the brackets as well, it's going to be x over 12 times by this thing. So it's going to be 4 pi x over 12. And then minus 3 root 3x over 12. And what I'm doing there is 2 times this is x over 12, and times that by that thing there. And then we've got plus 3x plus 2/3 pi x. And then let's simplify that down a little bit. So we've got 4 over 12, so that's 1/3. So minus 1/3 pi x plus 2/3 pi x, that's going to be plus 1/3 pi x. 1/3 pi x minus 3 root 3x over 12 plus 3x. Now what we've got here is we've got a fraction over 12. So let's put all of these things here over 12. So it's going to be 1000 over x plus 4 pi x over 12. Minus that one's already root 3x over 12 plus this one here is going to need to be 36x over 12. And it's just a matter of simple factorising out the x over 12. If we do that, we've got 1000 over x plus x over 12 on the outside, so that leaves with 4 pi minus 3 root 3 plus 36, which is what we've got down here, except in a slightly different order. So if you wanted to, you could then write that out again in the same order. Anyway, so that's how to get the first bunch of marks there. There's lots of stuff to go through there. And if you can do that, if you have followed that, well done. If not, don't beat yourself up too much. No one's expecting to get 100% in the exam. It's trying to pick up marks that you wouldn't usually get. So now what we've got to do, and this is the bit that I really want to do the video regarding, is using calculus to find the minimum value. Now calculus means integration or differentiation. In this case it means differentiation, because we're finding the minimum. Now if you picture a curve here, the way we use differentiation or calculus to work out the minimum of this thing, the minimum is this point here. Now the minimum is when the gradient is 0. So what we're going to do is whatever this function of x is, we're going to differentiate it, set it equal to 0, and then we're going to work out what that x coordinate is there. So in exactly the same way with this question here, we've got p, we're going to differentiate this, we're then going to set it equal to 0, and then we're going to work out what our value of x is, and then what our corresponding value of p is. So if we set this up so that we can actually differentiate it, so it's going to be 1000 x to the minus 1 plus x. If I say x times 1/12 of 4 pi plus 36 minus 3 root 3. Okay, so then we differentiate, so it's going to be dp we're differentiating p with respect to x. So that's going to be minus 1000 x to the minus 2. And here, just like if we had to differentiate 3x, the x just goes and you're left with 3. So here, we've got x times this thing here. But at the end of the day, this thing is just a number. So if we differentiate x times a number, you're just going to be left with a number. So we're going to be left with 1/12 of 4 pi plus 36 minus 3 root 3. So to find using calculus to find the minimum, we differentiate, which we've done here. We then set it equal to 0. Minus 1000 over x squared, because x minus 2 is over x squared, plus 1/12 4 pi plus 36 minus 3 root 3. And then we've got to solve it. So what we're going to do is we're going to bring this onto the other side. So we've got 1000 over x squared equals 1/12. Oh, it's boring, write this out over and over again. That's 36 minus 3 root 3. What we then do is we bring this x squared up to this side and bring this whole thing down underneath. So we've got x squared equals 1000 over 1/12 for pi plus 36 minus 3 root 3. And then what we're going to do is we're going to square root it. And then we're going to write that to the nearest, then we're going to have that as our value of x. So if we do that, we end up getting x equals, I'm going to pause the video so I can do that on my calculator, which is 16.63 ... Make sure you keep the answer in there. Now, what we've worked out is we've worked out the value of x. Now, that's the value of x that gives the minimum perimeter. So now what we've got to do is we've got to substitute x back into this thing here. So this value, just to clarify that, this value of x is the value of x which gives us the minimum. Now what we've got to do is we've got to substitute that back in. So if we do p equals 1000 over 16.6, and if you can, use the whole value, plus 16.63 over 12, lots of 4 pi plus 36. Not the shortest of questions, this one. But if you do that, I got myself off there, you should get 120.236 ... which is going to be 120 meters. So that's how you do it. That's how you find the minimum value. So that's how you use calculus. Whatever this is, doesn't matter if you've been able to find it or not, you differentiate it, you set it equal to 0, and that's going to give you your x, which finds your minimum value. You then have to substitute that back in. I'm going to see that work a couple more times. But just quick, before we do go on and see that, justify by further differentiation, so it means that we've got to differentiate again. So when we differentiated, we got this thing here. So to find out whether or not it's a maximum or a minimum or whatnot, what we do is we differentiate again. And differentiating again looks like d2p by dx squared. And if we do minus 1000 x to the minus 2, if we differentiate that, it's going to be minus 2000 x to the minus 3. And thankfully, this disappears. Whew. So that's not going to be minus 2000 at all, is it, Rescorla? That's going to be plus 2000, so it's 2000 x to the minus 3 over x to the power of minus 3. And then what you need to do is you need to substitute in your value of x, which gives you a minimum or a maximum. So if we do that, 2000 over 16.63 ... the power of 3. And then what happens is you find that gives you a value which is greater than 0. And if you then need to say that as it is a positive value, it is a minimum. If that had given you a positive value, so if it gives you a positive value, it's the minimum. If this gives you a negative value, it's the maximum, and they do ask that. And if it's equals 0, then it could be a point of inflection, or it could be something else, and you need to do some further differentiation or use a different method. But in all the questions I've seen on these types of questions, it's never equals 0. So if it's positive, it will give you a minimum. If it's negative, it will give you a maximum. So that's how to do this question. Now, this video is dragging on a bit, so let's move it on. 2015. What we've got here is we've got a solid glass cylinder which is used as an expensive laser amplifier, has a solid volume of Let's try that again. A solid glass cylinder which is used as an expensive laser amplifier has a volume of 75 pi centimeters cubed. The cost of polishing the surface area of this glass cylinder is £2 per centimeter square for the curved surface area, and £3 per centimeter square for the circular top and circular base. Let's do a quick diagram. So what we've got here, it tells that the radius is r. We've got the radius r. So then we've got the height there. And then the curved surface area of polishing that, which is this bit around here, that's going to be £2 per centimetre squared. And on the top, it's going to be £3 per centimetre squared, if we can get some context to this question. And we know that the volume equals 75 pi. So show that the cost of polishing the whole thing is going to be this thing here. So first of all, let's work out the area of the top and the area of the bottom. So we've got pi r squared, which is the area of the circle on the top. And we've got the area on the bottom as well, so that's going to be 2 pi r squared. So that's going to be the top circle and the bottom circle. And then we need to multiply that by £3. And that's going to be the cost of the top and the bottom. So that's going to equal 6 pi r squared. So yeah, looking good so far. And now what we've got is we've got the curved surface area, which is this bit around here. So the way you work out the area of that, that's going to be the circumference, which is pi times by the diameter. Then we're going to need to multiply that by the height. So, and then we're going to need to multiply that by £3. No, sorry, it's £2 for the curved surface area. So the diameter is 2r, so that's going to be pi times 2r times the height times 2. However, we don't know what the height is, but we're told that the volume is 75 pi. So the way you work out the volume of a cylinder is pi r squared, and you times that by the height. So we know that the volume, which is 75 pi, equals pi r squared times by the height. So therefore the height, if you divide both sides by pi r squared, divided by pi and the pi's go, it's going to be 75 over r squared. So the cost of polishing the curved surface area is going to be, as we set up here, pi times by 2r times by this 2 here, times by the height, which is 75 over r squared. So if we simplify that, that's going to be 150, 300 pi, and then one of these r's is going to cancel out with one of these r's, so 300 pi over r. So the total cost is going to be both those added together, leaving me with C equals 6 pi r squared plus 300 pi over r. Fantastic. So that's how you do that one. It's a little bit easier than the previous question, but 4 marks nonetheless if you can do it. And again, even if you can't do it, it doesn't matter, because we're going back to this question here, where we've got to use calculus to find the minimum cost. So in exactly the same way as last time, we're going to differentiate. So dc, we're differentiating c with respect to r this time. So that's going to be 12 pi r, plus, and then if we bring this up to the top, that's going to be minus, going to bring the minus down, 300 pi r power of minus 2. So we differentiate it to find the minimum. We then set it equal to 0. So we've got 0 equals 12 pi r minus 300 pi over r squared. We're then going to move this over to the right hand side. So it's going to be 300 pi over r squared equals 12 pi r. So then we're going to rearrange stuff. So we're going to bring the r squared up to make r cubed. We're going to divide through by 12 pi. And that gives us r cubed equals, divided through by pi, 300 divided by 12 is going to be 25. So it's not quite a nice number. But then if we do 25 divided by the cube root of 25, we're going to get r equals 2.92 dot 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 dot. So that's the value of r, which gives us the minimum. What we've then got to do is we've got to substitute that back into the thing which tells us the cost, and that's going to be our minimum cost. So if we substitute 2.92, or the whole answer in your calculator, back into this, then if I just pause the video, I'll tell you what the answer will be. And it gives us our cost, which is 483.48. But we've got to do that to the nearest pound, so that gives us an answer of 483 pounds. Okay, and again, part C, in exactly the same way as in 2016, we should be able to spot a pattern, is that we've got to justify that it is a minimum. So the way we do that is we differentiate again. So d2c by dr squared. If we differentiate this again, we're going to get 12 pi plus 600 pi r to the minus 3. And then we substitute in our 2.92. So substitute in, so sub x equals 2.92 into d2c by dr squared, and we then get d2c by dr squared. It should give you something positive, as you can see. It's not going to be a negative thing, because that's going to be positive, that's going to be positive. If I was you, I'd actually go through that and work out what that equals. Then you need to say that is going to be greater than 0. Therefore, it's a minimum. Okay, finally, in exactly the same way, we've got another big old question here. But again, it's a big topic, so if you can get this, it is worth a lot of marks, which is why it's worth persevering with this video. So we've got this thing here. And we've told that the volume is that. So we've now got to show that y equals this thing here. So the way we're going to work out the volumes, we're going to work out the area of the cross section. We're going to times it by y, and we're going to say that equals 9,600. So 9,600 equals y times by the area of the cross section. So the way you work out the area of a cross section of a trapezium is we're going to do 9x plus 6x. So 9x plus 6x divided by 2, and we times that by the distance between them, so times by 4x. And if we do so, that's going to be 15x divided by 2, which is 7.5x, times by 4 is 30x squared. So we've got 9,600 equals y times 30x squared. So we need to divide by 30x squared, so y equals 9,600 divided by 30x squared, which equals 320 over x squared. So nice quick couple of marks there. Hence, the surface area of this letterbox is this here. So in exactly the same way, we're going to work out the area of all the surfaces, add them together. So the surface area, we already know that the area of this surface here is 30x squared. So it's going to be 30x squared plus 30x squared, because you've got the one on the other side. So we're going to work out this surface area here, which is y times by the height, so that's going to be plus 6xy. The floor down here is going to be 4x times by y, so plus 4xy. Then we're going to work out what the back is up here. That's going to be plus 9xy, plus this one here, and that's y times by the slope, which is 5x, so plus 5xy. So if we do that, we've got 60x squared plus 10, 19, 24 xy, and that's the surface area. However, we want it looking like this thing here. So we've got the 60x squared, that's good. But then we don't know what y is. But we do, because y is 320 over x squared. So the surface area is going to be 60x squared plus 24x times by 320 over x squared. The x is cancelled out there. And 24 times 320, surface area gives us 60x squared plus 7,680 over x. Again, that seems a little simpler than the 2016 one. But nonetheless, we can get the answer. Next one. Use calculus to find the minimum value of s. So again, it's the same question. So if this question comes up, there should be no excuse, especially if you've watched this video. It's the same thing over and over again. And that's the whole thing with the revision of maths. If you've seen these questions sort of 1, 2, 3 times, seen it a fourth time, you should be golden for the marks. Anyway, use calculus to find the minimum in exactly the same way as the past two questions. We do ds by dx because we're differentiating s, and x is the variable here. So if we make that x to minus 1, that's going to give us 120x minus 7,680 x to the minus 2. And then once we've done that, we set it equal to 0. So we've got 0 equals 120x minus 7,680 over x squared. Bring us to the other side, and then we're going to bring the x squared up. So it's going to be 7,680 equals 120. We're going to bring the x squared up to there. It's going to be x cubed divided by 120, and we've got x cubed equals 7,680 divided by 120, which is 64. That's nicer. Then x equals 4. However, that's not our minimum value of s. That is the value of x, which gives us the minimum value, which hopefully, if you follow the videos carefully, you'll know by now. So then, if we substitute that into s equals, so 60 times by 4 squared plus 7,680 divided by 4, we should get 2,880 centimeters squared. Again, just by further differentiation, it's exactly the same question. So what we're going to do is we're going to differentiate this again. So d2s by dx squared, that just goes to 120 plus, if we times that, so 7,680 times by 2. Don't make a silly mistake now. So actually differentiate it, also multiply it by 2 properly. So 15360 x to the minus 3, which if we then bring that underneath, we're then going to sub in, so sub in x equals 4, and d2f by dx squared equals, then write down what that equals, and then that obviously it's going to be a positive thing, so we say that d2s by dx squared is greater than 0, therefore it's a minimum. Again, remember, if it was negative, if it was less than 0, it would be a maximum. But yeah, well done on that video. It's quite a long one, but again, it's quite an important one. So good luck.